Okay, so we're doing some guided practice. So I'm going to want you to give it a shot first. We are on page 6.6 right now. So if you're not there already, you need to pause it right now and get to the page before continuing. Okay, so we're on page 6.6. First thing you want to do is you want to try to annotate the problem. So I want you to circle what we know and put a box around what we're trying to find. Pause it and try that. Okay, so we know that there are 32 grams of oxygen, and we're looking for particles of magnesium oxide. Next thing you need to do is plan out your conversion. So use your conversion diagram and go ahead and do that. Okay, so now the video's unpaused. So grams of oxygen, oxygen's going to be our A, magnesium oxide will be our B. So we're starting at mass of A, we're going to amount of B. To get there, we go to mole A, then to mole B. Okay, so we start with 32 grams of O2. Go ahead and pause and finish that conversion. Alright, let's see if you're right. So put grams O2 on the bottom to cancel. We'll go to moles O2. We use the molar mass, which is 1 mole of O2 for 32 grams of O2. Grams O2 cancels out. We're left with 1 mole of O2. Alright, so we're going to take that down and do our next conversion. So go ahead and try to do that next conversion. We're going mole A to mole B now. Remember what B was? We annotated it right here. Pause and try that. Okay, so we put moles O2 on the bottom, and we're looking for moles of B, so mole of magnesium oxide, which is MgO, and we use our conversion diagram to tell us to use the coefficients. So for every 2 MgO that you create, you use 1 O2. So O2 cancels out. We're left with 2 moles of MgO. Alright, so now we're going to bring that down and do our last conversion. So we do 2 moles of MgO. Go ahead and pause, do your conversion. Once you're done, unpause the video. Alright, so moles of MgO, put on the bottom to cancel out. We're looking for amount, which would be particles of MgO, because it says how many particles up here. So we know that there are 6.02 times 10 to the 23rd particles for every 1 mole of MgO. So that cancels out, and we convert it. We get 1.204 times 10 to the 24th, which is 12, but I just moved the decimal over. Particles of MgO. Okay, so that's that one, and you can put in a sentence too. If you need to replay that one, go ahead. And let's do the second one. Make sure you're pausing when I tell you to. Alright, number 2, still using the same reaction. This 2Mg plus O2 goes to MgO. First thing we want to do is annotate it. So pause the video, annotate it. Once you've got it annotated, unpause it. Okay, so we're going to circle what's given to us, which is 5.6 liters at STP, which is important. And we're looking for grams of magnesium. Pause it, plan the conversion out. So we're starting at volume of A, oxygen's going to be A, and we're going to mass of B, magnesium's going to be B, because it's a different chemical, that's why it's not A. So we have to go mole A to mole B to mass B. So this is another 3-stepper. They're not all going to be 3 steps, but if you can do the 3 steps, then you're in good shape. Alright, here's our 5.6 liters of O2. Pause it, set up the conversion. Once you're done, unpause the video. So to do this, we do liters of O2 to cancel out, and we're going to put moles of, it's still A, O2 on top. It's at STP, which means 1 mole of O2 is equal to 22.4 liters. Liters cancels, we get 0.25 moles of O2. So I'm going to bring that down. 0.25 moles of O2. And we're going to convert. Pause the video, try it, unpause the video. Alright, so we put moles of O2 on the bottom. Why do I put moles of O2 on the bottom? Oh yeah, to cancel it out, because that's what I'm coming from. And then I put moles of B. What was B? Magnesium. So I put moles of magnesium on the top. And then, where did I get the conversion factor from? The numbers? I can look at my diagram, and it tells me to use the chemical equation. So I'm going to get the coefficients. So there's 2 Mg used for every 1 O2 used. So you do your math, you get 0.5 moles of Mg. Alright. So now we do our final conversion. So go ahead and pause and do that. Okay, so we put moles of Mg on the bottom. We put grams of Mg on the top, and then we choose our molar mass. Don't even have to calculate it because it's just one thing. Alright, and you do your math, you get 12 grams of Mg. Alright, so then if I want to react 5.6 liters of oxygen, you must have burnt 12 grams of magnesium. This is the one we did, by the way, with the silvery magnesium that we lit on fire that was like brilliant, bright white. That's magnesium burning. Okay, so now for just about the rest of the period, you're going to work on pages 6 and 7. You're just going to finish. I have a video which is going to go over the answers. It's pretty much just an answer key that I'm kind of going to talk you through. I'm not going to do it in real time. So try it on your own first. You can work with your partner, but you need to be able to do it. So just copying from your partner is not a good idea. Be responsible about using the key. When you're done, you can start your homework. And then in the last 10 minutes of class, you should do the exit slip, and there's a grading video for it once you're done. All right, and then you'll want to pass those in, because I'd like to take a look at that and see if we're getting better or not. Because so far I'd say about 1/3 of people have got it, but we still need to get the other 2/3 to understand the material. Okay, so have fun practicing. I'll see you Friday.